So you know that many organizations sync their local AD with Azure AD, and lately we see that more and more organizations or departments inside the organization, they don't use on-premise AD at all. They manage all the identities on Azure AD. So we have developed a new feature that will allow you to authenticate and authorize access against Azure AD IDP, Identity Provider, instead of using the traditional method of authenticating users against the on-premise Active Directory. So let's take a look on the use cases. The first use case is for authenticating users that are coming from the internet and want to access an application that is located behind an on-premise gateway. Before the gateway will allow the user to access the application, it would request the user or the user agent to authenticate against the Azure Identity Provider. The gateway doesn't need to be a physical appliance. It can be a virtual appliance that can be deployed on a private cloud or public cloud. We don't really care where the gateway is being deployed. Any public cloud provider will work. The second use case is that you will want to authenticate your users that are located behind the gateway internally and will want to access external applications. And this is similar to the traditional approach of authenticating users against your on-premise Active Directory that many organizations use, but this time we authenticate and authorize access based on Azure AD users and groups. And by the way, if a user already authenticated against the IDP on access to Office 365 or other application, we won't need to authenticate again. The authentication will run in the background against the gateway. Now, working with the Azure AD requires two separate mechanisms, one for authentication and one for authorization. Authentication confirms that the users are who they say they are. Authorization gives those users permission to access a resource. The authorization is controlled from the policy. We will create a rule that will allow specific user, Azure AD user or group, to access a specific destination. The authentication flow will be run against Azure IDP by using SAML authentication and Checkpoint Captive Portal. So let's take a look into a SAML authentication process. We have an R81 gateway that protects a web application. A user that is located on the internet will open a web browser and will access the public IP of the web application. The gateway, which in the SAML terminology is the service provider, will catch this HTTP or HTTP traffic request and will redirect the user to the captive portal, which will redirect the user to the IDP, the Identity Service Provider, which in our case is Azure AD. So once the user will put his Azure AD email and password and the authentication is successful against the IDP, the Azure IDP would generate two files. The first file is the SAML artifact file, which is a very small message that contains a unique identifier. The second file is the SAML assertion file that contains details about the user. The SAML artifact file is being sent to the user agent, and from the user agent to the service provider, which is the gateway in our case. The gateway send the artifact resolve message to the Azure IDP, and the Azure send back to the gateway the SAML assertion file that was generating upon user authentication. This is an XML file that is signed and hashed by the IDP. This file includes the method of authentication and of course attributes which provide more details about the user, the groups he belongs to, his email address, and other attributes that you can select that once you configure the Azure SSO configuration. And we are going to see it later on. So once the service provider trusts the user, he will redirect the user agent to the application that the user originally request. For the authorization part, we will need to configure a connector to Azure on the management, and once we create an access role, we will use the picker to select users and groups from the Azure Active Directory in the same way that we select users and groups from the Active Directory. The Smart Console doesn't need access to Azure. The management communicates directly with Azure and update the picker every few seconds. And this is from the management side. From the gateway side, the gateway is a local table and Azure DB table that is being updated every 30 seconds. The gateway query Azure every 30 seconds for users and groups membership, and update is local Azure table. On authorization request, the gateway will query the local table and not go to query Azure. This is much more reliable approach. So now that you understand how it works, let's configure it. In my lab, I'm going to simulate an internet user that will access an internal web application that is being protected by a gateway, and I will want to allow only the members of a specific Azure AD group to access this web application. So let's jump to the lab and configure it. Let's start from the policy. I have an access role that permits access on port 80 from any source to specific public IP. This public IP is knotted to an internal IP address which belongs to internal web server. So if I will open a browser to this IP address, this public IP address over port 80, I will get to the internal web server. I want to remind you that we will want to allow only specific users that their identities are being managed on Azure AD to access the web application. I will start from the Azure side. All the settings will be managed on the Azure Active Directory console. And I'm going to create a new enterprise application. I will create my own application. You can give it any name you want. I will give mine IDP. Now that the application has been created, I will navigate it back to the Azure AD main page, and from there to the app registration. I will select all application and select from there the application that I've just created. I will copy to Notepad the application client ID and directory ID. The application object that we have created can be referenced by one or more service principals. Now I will create a client secret and copy to my Notepad as well. For giving permissions on the directory for the SPN, I will use the API permission section. And I will need to add a few permissions. I will use the Microsoft Graph. And I will select the application permission. And the permission that I will need to add are the following: device read write all, group read all, and the last one is user read all. And don't forget to click the grant admin consent button. Now I will switch back to the enterprise application section, and I will select the application that I've just created, the IDP. And I'm going to configure the SAML authentication section. The settings are on the SSO menu. On the basic SAML configuration menu, I will need to set the service provider identifier and reply URL. And in order to do that, I will need to set the IDP object on the checkpoint side. I will start by enabling the identity awareness blade on the gateway object. I will close the wizard as I'm going to configure the setting manually. I will activate the browser-based authentication as identity source. Now that the IDA blade is enabled, I will create the identity provider object. This object is under the user and identities section. Just give it a name, and I will select the gateway. I have just one gateway, and I will select the identity awareness blade. And the reason that it let you to select a blade is because this feature is also supported on the mobile access blade. So if you will enable this blade, you will be able to use the IDP for the mobile access blade as well. I will copy the identifier that has been created automatically and paste it on the Azure identifier field on the SSO. I will copy the reply URL and I will also paste it on the Azure reply URL field. Now we need to change the unique user identifier attribute. I will change it to user.local user principal name. And now I will download the Federation data XML. And I will need to import it to the checkpoint IDP section. So let's publish, and we are done with the Azure side. One step that I forgot on the enterprise application, you will need to add the users and groups that are going to authenticate against this IDP. Now we'll edit the gateway object, and under the identity awareness section, I will activate the browser-based authentication as identity source. And on its setting, on the access setting accessibility, I will set the portal to be available through all interfaces. On the authentication setting, I will choose the identity provider that I have just created. I'm done with the gateway object, and now in order to be able to pull identities, users and groups to the access roles that I'm going to create, I will need to create a connector to Azure Active Directory, and I will do so by adding object Azure AD. This is the object name, Azure AD, and it's located on the identity and users menu. I will give it a name, and I will copy the values that I've copied earlier to Notepad. And we are almost there. Let's edit the access role. On the role that permit access to the web server, on the source section, I will create a new access role. I will add specific users from Azure AD to this access role. I will put over there just the user test. On the action section, I will check the captive portal. And now the policy is ready. I will push it and install policy. And let's test it. I will open the browser and I will access again the public IP of the web server over port 80. As the captive portal doesn't have a FQDN with a valid certificate, I'm seeing this error page, so I will proceed and move on. And now the captive portal is redirect me to the IDP, to the Azure Authentication page. And now that the authentication is successful, I'm getting redirect to the web server.